Good afternoon. This is Caroline Hazard with the Jump Into STEM team, and welcome to the first webinar in the series for the Round 2 challenge, Stop the Squander, Identifying Building Malfunctions That Waste Energy, and the challenge to design new methods for fault detection and diagnosis in buildings. Today, I'm going to go over a quick tour of the website and our other challenge that's open. And then I'm going to turn things over to Pilje, who will go over this challenge in more detail, as well as some of the data sets that are available for you to review and use in addressing the challenge. The purpose of Jump Into STEM is that we're trying to expand our reach to universities and college students. We're also really interested in making sure we pull more women and minorities into the STEM fields. So that's a big focus of our marketing efforts and encouraging teams to have diverse makeup so that we can have all inclusion for our responses. The Jump Into STEM program is also a flexible platform for university and college professors to engage in research and development activities with the Department of Energy and the labs by promoting the Jump Into STEM platform and the challenges here to reach the students. And ultimately, we're looking to try and motivate creative thinking and ideation among students to advance building research and innovation. Let me go over a quick overview of how to navigate the website. A lot of this information is already recorded from the previous webinar series, so I'm going to just quickly go over this. So if you're on the home page on jumpideascale.com, jump.ideascale.com, you should visit How It Works, where this big red arrow is. And there's a video there that goes over how this whole website works and things like that, and things you should pay attention to. So I encourage you to start there with that video. There's lots of information already contained on this website. Where my red arrow is now is where you will find access to clicking to each of the information cards on our round 1 and 2 challenges. Any current challenge that is open will be here. This picture is a little bit old, so it only says round 1. Currently, there's a second button here that says round 2 for the challenge that is now open and we will be presenting on to today. So when you click that button, whether it's round 1 or round 2, you'll end up with a card that looks like this, the card here on the right, where you can read about what the challenge is. And if you scroll down, you get more information about what we're looking for each challenge, including potential data resources, as well as any previously recorded webinars and additional links. So lots of information is contained in this piece here. Then when you're ready to, after you've formed your team and thought about what you'd like to submit as your idea, you click this button and you'll fill in a form that looks pretty much like this, where you'll offer your title. There's a brief text field to summarize your idea. And then you can also upload any PDFs or other data files or graphics and things like that associated with your idea, so that you know, it's all neat and packaged nicely. And then feel free to tag your idea and submit it. This is a brief overview of our schedule. You should check back frequently on the schedule button on the home page of jump.ideascale.com for any updates. This is where you can see that we're running the round 1 challenge through to the end of November, and round 2 is open also to the end of November. So you need to think about your ideas and get them submitted. Then we'll do judging in the beginning of December and make our announcement at the end of the calendar year, promoting the winners there. I should have mentioned in the beginning of this whole presentation that each of these rounds, there'll be a third challenge, starting probably, this should slide over a bit to the November timeframe, but each has a down select of a winner. These winners will compete for a final event that culminates with the finalists that are selected there as the winners for summer internship at either NREL's National Renewable Energy Laboratory in Colorado or at Oak Ridge National Lab. So those are really significant award opportunities. Those that are down selected to get into that process also have the opportunity to be promoted and really receive the benefit of mentorship from the laboratories as they move through the progression of their idea. So again, this is the link to see the updated schedule should anything change or get added. So just briefly, just to give you a snapshot of what the round one challenge topic is, it is using the right data at the right time to improve residential building performance. I'm not going to read this card, but we're looking for folks to think about how we can effectively, do things like baseline the home's energy use, or maybe perhaps the specific end uses in the building, so that we can better understand what's going on. Maybe experimental models to think about how to influence energy use behaviors, or even visualization tools and methods to communicate the performance of the building, since there's a lot of data that is accessible, and a lot of times we don't know how to best communicate that. So your ideas are what we're looking for here. Definitely check out the recordings. You now know where to find them. They're right at the bottom of the challenge write-up. There are 3, and they have lots of great information for you to use and think about as you formulate your idea. So with that, I'm going to turn it over to Piljay. Piljay is currently serving as R&D staff in the Building Envelope and Urban Systems Research Group in the Building Technologies and Research Integration Center at Oak Ridge National Lab. He received his PhD and Master's of Science degree in Architecture from Texas A&M University. Since he joined Oak Ridge National Lab in 2009, he has served as the principal investigator and co-investigator for numerous research projects sponsored by DOE's Building Technology Office, as well as the U.S. Department of Defense, and also domestic and international industry partners. Piljay's research has focused on detailed calibration of building energy simulation models based on field measured data, development of prototype building models, and validation and uncertainty characterization for energy simulations. So we're really in a great spot here to have Piljay available to talk to us about round 2. So Piljay, would you like to get started?
Sure, yeah. Hello everyone, thanks for a nice introduction, Caroline. And today I'm going to review the Jump into STEM Challenge round 2, like what the challenge is and what's the purpose and how you can address the challenge. The webinar will be starting from a brief introduction of automatic fault detection and diagnostics, which we call FDD here. And then I will explain how the fault data has been created using one of our test buildings in the lab. And also I show some sample fault test results, and the presentation will be concluded with the review of the Jump into STEM Challenge round 2. Next slide. So first, let's look at the outlook of the energy use in United States. When we look at the energy use, as you can see, the building sector is using almost half of all energy produced in the United States. If we look at the electricity use only, building sector is using almost 3/4 of all electricity produced. This costs us about $410 billion every year. Next. So is this inevitable? Of course, we can reduce the building energy use by implementing many available energy efficient technologies such as better building materials, high efficient windows, or high performance HVAC systems. But in other hand, building energy use can be simply reduced by correcting the faults frequently found in commercial buildings. According to a study in commercial building, it is estimated that annual building energy use can be cut by an average of 29%, or 4 to 5% of overall national energy consumption through corrections to existing building controls infrastructure and resulting improvement to operating efficiency. It is also known that equipment faults and control errors in commercial buildings waste an estimated 1 quadrillion BTU of primary energy annually. So we can see there is a great opportunity here to save energy. As a way of finding and analyzing the building faults, various automatic fault detection and diagnostics methods have been studied, developed, and implemented in buildings for many years. AFDD is an automated procedure of investigating faults and identifying the location and causes of abnormal symptoms. Next. So I'm showing in here the classification of the existing FDD methods. In general, the existing FDD algorithms can be classified by 3 different methods, which are quantitative model basis, qualitative model basis, and process history based. First 2 are model-based approaches, and the other one is basically a data-driven approach. Model-based approaches use quantitative or qualitative relationship based on the underlying physics of processes. Of this, you can see the rule-based method, specifically expert system, is quite popular. The expert system consists of many if and then statements to find the fault and the cause. While these 2 methods use a priori knowledge of building and system and process, the data-driven model, which is the process history-based model, is solely rely on historical process data. As this method does not need priori knowledge, and also as more building operation data is available in these days, this data-driven method is getting more attention recently. Basically, this method is using black box or gray box method to describe the input and output relationship and find any anomalies in the data. The more details regarding the existing AFDD methodology can be found in several studies, including one shown in this slide, the bottom of this slide. Next. So DOE Department of Energy has sponsored many AFDD related research, and one of the existing projects is shown here, hybrid model based algorithms for whole building AFDD. This project is to develop a novel model-based AFDD platform that leverages whole building physics-based energy models to provide fault detection and diagnosis. This project combines the building energy modeling capabilities of Energy Plus and OpenStudio ecosystem, which is the flagship of energy modeling software of Department of Energy, with the analysis of diagnostics capabilities of GE's Predix cloud computing platform. The more details of this project can be found in the link shown in the slide, bottom of the slide. Next. So one of the tasks in this current project is to generate the quality fault data from a real building to validate the developed algorithm from the project. Oak Ridge National Laboratory has an occupancy emulated small office building shown in here, which is called Flexible Research Platform, or FRP. And we are using the FRP to implement the various building faults and generate the detailed building operational data. I will describe the more details of this jump-in system challenge round 2 later in this webinar, but basically, some of the data generated from this project, this building, FRP, will be provided with this challenge to be used in developing a new AFDD method for you. So I will spare some time here to describe the building and system characteristics for your understanding. The FRP is a two-story small office building. There are 10 conditioned rooms in the building, 5 in the first floor and 5 in the second floor. And each room has a VAV box, variable air volume box with the terminal reheating. The 10 VAV boxes are connected to the conventional rooftop unit through the duct. One unique aspect of this building is that the occupancy of this building is emulated. So there is nobody living in this building, but we emulated the occupancy. The reason is that because the variation of occupancy behavior in typical building, in real buildings, is one of the main uncertainties in building energy use pattern and the amount. This building eliminated this uncertainty by emulating the typical occupancy every day. So this can generate more clean data sets for validation purpose. I will explain a little bit more about the occupancy emulator later in this presentation. Next. So there's a table, and this table shows the summary of the building and system characteristics in case you would like to know more about the building. Building is located in the Oak Ridge, Tennessee, inside of our lab, and it's 40 by 40 feet with 2-story. The building was designed to be a typical small building, office building built in 1980s. So you can see the many building features are not up to date in terms of energy efficiency. Next. This slide shows the simple diagram of the system installed at the FRP and the data measurement points as well. Basically, there are power measurement for the HVAC and whole building level. And we also measure the zone temperature and relative humidity and some other measurement like airflow rate from that RTU unit. Next. Previously, I mentioned about the occupancy emulation of this building briefly, and this is some more details in here. So in order to correctly reflect the occupancy patterns of typical office buildings, several literatures shown here were reviewed, and the typical occupancy schedule, including lighting and plug load were defined, shown in the slide. Then the sensible, next. And then the sensible and latent internal heat from the building were emulated using portable heaters and humidifiers and with some control. Basically, occupants and then other building equipment like a computer and lighting equipment will generate the latent, sensible heat and latent heat, and then we calculated this amount of the heat and generated based on the typical schedule inside of the building. So everyday operation of this building can be exactly identical, including occupancy behavior. So we can get some more consistent data out of this building. Only difference would be the weather variation today, because we cannot control the weather outside. Next. So now we have some understanding of this test building. Let's get into the fault test we've done so far. First, we identified the typical faults that are frequently found in commercial buildings and implemented the fault to the FRP in summer and winter season. This slide shows the list of the faults we've implemented. there are some faults specifically related to the rooftop unit system itself, such as RTU supply duct leakage, condenser fouling, and lower or higher refrigerant charge level. In addition, there are some faults related to the thermostat and lighting control. Next. So now let's look at some example of the fault test result. This is not obviously part of our challenge data set, but challenge data set will have the similar structure like a baseline operation and fault operation shown in here. So there was a fault test named excessive infiltration. This is not really typical HVAC system related fault, but you may consider this as more about building operational fault. Imagine that someone opened a window or door by accident, and this can introduce excessive outside air into the building. And as a result, this can increase the building's cooling and heating loads and energy, and also this can affect the occupant's comfort as well. So in order to implement this fault, we estimated the building infiltration rate with some windows openings in 2 rooms to mimic about around 20% and 40% more building infiltration during winter season for this test. With this setup, we have monitored the data for baseline operation, which means no fault implemented, all the windows closed, and 20% and 40% excessive infiltration rate case. The building was conditioned with 70 degrees Fahrenheit heating thermostat set point during occupied hours, which is the 7 a.m. to 10 p.m. And also we have unoccupied hours, the 60 degree Fahrenheit setback thermostat schedule. Next. So this slide shows the result. We have much more data in here, but I'm just selecting 4 key plots to explain the result. So first plot, upper left side, shows that the outdoor air temperature during the test. So although those 3 days were in the same week, each close to each other, the outdoor air temperature profile is slightly different, which should also be considered in analyzing the fault. So we cannot control the outside air temperature, so it's kind of inevitable in here. And the second plot, upper right corner, the second plot shows the RTU, which is a rooftop energy used for 3 scenarios. As you can see, in general, both the excessive infiltration cases shows higher RTU energy use during occupied period, not necessarily because of the fault, but mainly due to the higher outside air temperature for both fault test cases compared to the baseline test. This RTU energy use basically cooling energy use. So when we have a higher temperature, like 20% to 40% infiltration test case, we can have a higher cooling energy use during the occupied hours. But one thing noticed here is that there are some RTU energy use even during the unoccupied hours, especially for the 40% fault case in the green line. The region of this can be found in the 2 plots in below. So these are the reheating energy used for 2 rooms whose windows were open during the fault test. So due to the excessive outside air infiltration, especially for the 40% case, the room temperature in room 106 can be goes below the setback thermostat set point temperature, which is the 60 degrees Fahrenheit. So RTU and VAB reading system should be temporarily kicked on during the unoccupied period to maintain the setback thermostat set point. I didn't show that the temperature zone temperature profile in here, but you can imagine that if you look at the room ownership temperature profile during the unoccupied hours in 40% fault test, in some point temperature goes way below than 60 degrees Fahrenheit, and reheating kicked on, and then zone temperature tried to maintain 60 degrees Fahrenheit. Next. So now we saw some samples and buildings, and now finally I will explain the jump into STEM challenge round 2. As mentioned several times, the purpose of this challenge is to develop new methods to accurately and efficiently identify when faults occur and the type of fault based on different levels of available information. Interesting part is in here we are going to provide 3 different levels of the data sets. First one is whole building energy use data, which combines all HVAC energy use, lighting, and plug load. And second set of the data will be sub-metered energy use that includes separated lighting, plug load, HVAC fan, compressor, reheating energy use. And finally, as a third level set, we will provide all data with zone thermostat set point and actual zone temperature, so the different FDD methods can be developed per different scenario. The purpose of this different level of the data is because in reality, as a building owner or building operator, you may find there is only whole building energy use available. And sometimes the building has more sensor or more building energy management system associated in there, so you can find more sub-metered data, or sometimes you can have more data about the zone thermostat set point or zone temperature profile in very detailed level. And even though I didn't show in here, and sometimes you can have a lot of more data associated with the building operation. So we try to mimic the reality in here by providing 3 different sets of the data. And also, we also encourage participants to develop a straightforward system of notifying and visualizing the fault and its impact for building owners. So when building owners see the anomalies in the building operation data, it can be easily understood, and then they can catch when it happened and what is that the fault in there. For example, this includes new algorithms and process flow chart and visual interfaces. Next. So we are looking for your idea like how to identify when the fault occur and what type of fault, and what's the method that can be used when you have different levels of data. And if you can find the fault, you may also estimate the energy savings by correcting those faults, which means you already have a baseline data, but if in the fault event, if there is no fault, the building will be running like the baseline, but with the different weather condition outside. So with the different weather condition outside, if you don't have the fault, what's the energy consumption? That's some kind of the modified baseline energy. And when you compare this modified baseline energy with the actual fault event, you may be able to, you can calculate energy savings and associated cost savings by multiplying the typical electricity rate, utility bill rate, and those kind of things. And again, we are encouraging participants to visualize the fault to help building owners and operators to easily find the errors and analyze the errors. Next. The data sets we are providing has 2 fault events, and which with the baseline data as well. So each data set will have a baseline operation and the fault data. And fault data set can have a different level of the fault, like I showed in the excessive infiltration. So if you remember, there's a baseline operation and there's a two fault operation, like 20% excessive infiltration and 40% excessive infiltration. So this data set can have the same fault event, like two of the fault events per each fault. And data resolution is a 1 minute level, so it's quite detailed, the data, the resolution. For your convenience, you can make this data 15 minutes on 1 hour if it is much easier for you to analyze the data. And as I mentioned, the data will be given at 3 different levels, as mentioned in the previous slide. Next. So let's look at the data set. As Caroline showed, when you go to the Jump into STEM website, now you can find the challenge round 2. And when you click that button, you can find the link for the data and some notes at the bottom of the web page. And it has that note for each fault, and then data legend, and then data set. And when you look at the data legend file available in the link, this file shows the data points and their description as shown in this slide. As you can see in this slide, it's small, so you can probably open that data legend right now. And there are room temperature data for the individual room, and of course outdoor air temperature and relative humidity data, as well as the sub-metered power consumption data. Next. So let's look at the fault number 1 data for level 1 first. This will look like this in the right side. And if you open the note for the fault 1, this will show that out of this whole data set, what's the baseline data. I revealed the baseline date. For this fault 1, we have 3 days of the baseline operation, which is January 30, February 4th, and 5th. And we also have a cooling and heating set point for this building during the occupied hours and then unoccupied hours. And as expected, this is level 1 data. It's very simple. And you have a date and time, and atmospheric pressure level, and then outside air temperature, relative humidity, and then combine the whole building, the energy consumption. Next. Level 2 data set will show lots of more additional information, and then this additional information shown in the orange square box in this, it's additional data. This includes detailed sub-metered power consumption, like compressor power and fan power and condenser power, and we also listed the plug load for the 10 rooms and lighting power as well. The plug load for 10 rooms will be very redundant because, as you may recall, this plug load is basically occupancy emulation. So every day, this plug load is supposed to be very similar to each other. Next. So for level 3 data set, there is additional information shown in the orange square box as well. This is basically zone temperature for the 10 rooms, and then that information can be also used to find out the anomalies in the building operation data. Next. So this concludes the presentation today, and more information and questions, you can visit the website, our website, and then if you have any comment and questions, you can contact us. And so we are looking forward to finding many great ideas from everyone. And thank you.
Thank you, Piljay. Very interesting and a good challenge for people to think about what's going on with these data sets. I should have let folks know if they have questions, you can type those in or you can raise your hand and we can try and answer those. And if you do not have any questions right now, but later, if you might have questions, we can address those via the FAQ process. So while I wait for a couple of questions to potentially come in, I'm going to try and go over to the actual challenge here. Let's see if this works. Piljay, can you tell me if you see my screen while this is moving around?
Yeah, I can see your screen.
Great. Okay, so I clicked on the round 2 button. As you can see, this is the challenge that Piljay just described. Later, I will post a recording of this actual webinar right here. Here's where you can register for future webinars. We have another one coming up on October 26th. That's Friday. That should be really exciting with Steve Frank from the National Renewable Energy Laboratory. He's going to give an overview of building performance fault detection and diagnosis, kind of get a little bit more deep into what the issues are and how to think about it. And then later in the month, on the 30th, we have a great presentation prepared with a gentleman from Michigan State University, where he'll go over some of the challenges the university has faced in thinking about managing their buildings and how fault detection is really important for that. This is no longer tentative. This is I need to fix that. It's a confirmed date. So, but the data sets that Piljay was going over, they're right here. So each of these, if you can see maybe through the interwebs here, that my pointer has turned into a hand. If you click these, you will be able to download any of these files. So please do that and get started on those things. At this point, I'm not seeing any questions or raised hands. So I'll go back to the presentation. Oh, I see a hand come up. Let's see. So Alex, let me see if I can get you unmuted here, because we've got a pretty light crew. I am not able to figure out how to do this. Hold on 1 second longer. Alex, are you there? Would you like to ask your question verbally? All right, let's see if Alex wrote it into the question field. How do we submit and in what format? Is text better? So while I show where that is on the screen, Piljay, would you like to kind of try and answer what format would be better?
In the final, the answers for, we don't specify the final format, so I think it can be like a report kind of the things, or you can give us some kind of poster type of the illustration and those kind of things. But if you actually develop some algorithm or code, that can be also associated with the final format of the report.
Mm-hmm. Okay. So if Alex, you or folks you're working with have an idea they want to submit, let's say they've reviewed all this, they've thought about things, they've worked on it on their computers and using software or modeling tools or whatever you need to do that, you can do that and then package it. I would encourage you to use tools to help visualize it, because that is one of the questions about how to visualize and describe these faults. Make that file into a PDF is my recommendation and attach it. So what you're going to do is you're going to click this button, which I just clicked, and hopefully it'll come up on your screen here. So you're going to get this form, and you're going to put in, like in this case, I was looking at the fault detection challenge. If you were responding to one of the others, you'd change it. But in this case, it's the fault detection. I will just say this is test. Oops, I don't know how to type. Test by Caroline. And And I can say my testing idea. And then right down here, I can click this button and I could add you know, whatever file I wanted to add. You would obviously want to type a little bit more here, and you'd want to give enough information to give a sense that your idea is a valid idea so that the moderator knows that this is a real thing. And then you click submit. So that will then send this along. Let's just try it, and I'll cancel this later in the background. And it'll say that I submitted this. For you to be able to do this, you need to be registered. So you need to be registered and set up your account, and then you're going to be able to do all these things. So you're going to need to say that you're, whether you're a legal resident of the United States and the District of Columbia, whether you're 18 years of age or older. It's not on this. Oh, yes, it is. It's right here. You need to be a college student or a university student. So those three things are requirements for participation in the program. So you must be a student, you must be 18 years of age or older, or a U.S. legal resident to participate. So let's see if we have any other questions that have come in. Okay, it looks like Alex feels good about that. Okay, so I'm not seeing any other questions in here. Again, thank you so much for your participation today. We will put a recording of this up on the site. Here's a recap for the upcoming webinars. Do sign up for those. There'll be lots more information to help you think about your ideation for this challenge. And then I also want to put a plug in there that you should check back towards the end of the month or in early November. We will be posting the next and third challenge for the fall series. This is round 3, pushing the envelope with wall retrofit designs. We'll be looking at using a base case house to design a wall retrofit product that should meet local code, address material needs, efficiency levels, and airtightness, and the like. We want to see demonstrated performance for moisture and airtightness and improved energy performance. So more details to come on that in early November, as well as an associated webinar series. So great opportunity for more creative thinking and opportunities for competition. So thanks so much for your participation today. Thank you, Piljay, for putting together a great deck and some awesome data for the students to use. And I hope everyone has a great afternoon.